Welcome students, this is a video on center of mass. What is center of mass and how to solve the center of mass problems? Center of mass is an important concept in a system of many particles. Center of mass is a point where whole mass of the system can be supposed to be concentrated and motion of the system can be defined in terms of center of mass. It is the mass weighted average of its component. So basically, if a system contains many particles, it will be difficult to treat them. So we create a center of mass position for a system and treat the whole mass is concentrated there and define the motion of the system as per them. It can be calculated as x coordinate of the center of mass can be calculated as m1 x1 plus m2 x2 plus m3 x2 divided by m1 plus m2 plus m3. So basically it is a summation of mass and the x component of the particle divided by the sum of all the masses. Similarly, the y coordinate of center of mass is defined as the sum of mass and y coordinate of the system of particles divided by the sum of masses. Again, the z coordinate of center of mass is defined as a summation of mass and the z coordinate of the system of particles divided by the sum of masses. The coordinates of the center of mass depends on reference frame, but its physical location is independent of the choice of the frame. Basically, it means that the xcm, ycm, zcms could be different as per the reference frames, but the physical location of the center of mass remains same. How to solve center of mass problems? Velocity and acceleration of the center of mass is given by Vcm is equal to summation of mass into velocity of each system of particle divided by the sum of masses. Similarly, acceleration of center mass is given by mass into acceleration of each particle divided by the sum of masses. So if we know the velocity of each particles and the mass of each particle, we can calculate the center of mass velocity. Similarly, if we know the acceleration, we can find the acceleration of the center of mass also. In the absence of external force, velocity of center of mass of the system remains constant, or we can say that center of mass moves with a constant velocity in absence of external force, that is no acceleration. By this basically we mean that if there is no force acting on the system, here no force means the net external force. If there is no net external force acting on the system, the center of mass system remains constant, that is it remains at same velocity. If it is at rest, it will remain at rest. If it is moving with some velocity, it will keep moving with that same velocity. The motion of the system of particles can be understood easily as the translation motion of the center of mass and rotation of particles around the center of mass. So let's just take a rod. If you hit a rod at one point, the rod will move also and will rotate also. So the motion of the rod can be explained in terms of center of mass. The rod will be rotating by the axis of its center of mass, and the center of mass will also be moving with some translation motion. Let us take one example. 4 particles of same mass lies in xy plane. The xy coordinates of the positions are 2, 2, 3, 3, -1, 2, -1, -1 respectively. Find the position of the center of mass system. Now in these type of problems, it's like quite simple problem. We know the coordinates of all the 4 particles and we need to find the center of mass. So as studied before, it can be simply calculated using the formula given below. So now let us move to the solution. So since here we are just talking about the xy plane, we can remove the z coordinate. Let us assume m be the mass of each particle. Then x coordinate of center of mass will be equal to 2m plus 3m minus m divided by m plus m plus m, that is equal to 3 by 4. Similarly, the y coordinate of the center of mass can be calculated as 2m plus 3m plus 2m minus m divided by m plus m. Again, that is equal to 6 by 4, equal to 3 by 2. So the center of mass coordinates are 3 by 4, 3 by 2. Let's take another question. A rocket following a parabolic path in air suddenly explodes into 2 parts. What can be told about the center of mass of the system after explosion? There are 4 options given. Vertically downwards, horizontally, it will move along the same parabolic path which the intact shell was moving. It will move along the tangent to the parabolic path at the point of explosion. So the solution, now we know that center of mass motion depends on the next external force. Since net external force, gravity remains constant before and after, the center of mass will keep moving in the same direction. For more tips and study material, please visit our website physicsatlas.com.